Welcome to the class Flooding 101, and I'm your professor, Dr. Elaine, and I'm here to show you how to make some calculations. Yeah, okay. So, I made up some stuff. So the first thing is, how fast and how long did the flood last? And so what MacGyver's going to measure is two things. One, so here's some dirt wall that flooded, and there's like a little cutout part where the maximum water level was. So he needs to measure two things. One, the height of that cutout, which tells you how deep the flood water was. And two, how deep into the wall that goes. So I call that X and that H. And I made up some numbers, but I put it in a program so I can change those to make whatever you want. But I said the cut in was 12 centimeters or 0.12 meters, and this was 0.9 meters high. Just made something up. Okay. Now, the first thing is, how long did the flood last? It's the first thing I can calculate. And in order to do that, I need the height and some factor, which I call the flood decay factor, which I put over here, decay constant, C. So I said the flood is drops 0.05 meters per hour. So if I know that this height is 0.9 meters, I can calculate the flood time. And the flood time I get 18 hours, and you can convert that to seconds, which I will do in just a second. Okay, so next I need the flow rate. So the flow rate depends on how much this is cut in, and so that depends on how long it was cut in and how fast the water is moving. So I have this other factor here called the erosion factor, which I made up. And the erosion factor, I picked a value of 2 times 10 to the negative fifth, no units. And so I can calculate the flow rate as the cut-in amount, x, divided by r times t, where that's the t I just calculated. And I converted it to seconds, and I get 0.09 meters per second. So I know how long the flood lasted, 18 hours, and it was moving at 0.09 meters per second. Okay, now, where does the crate go? Okay, so here's my crate. It's a box, and it's L by L. So I picked 0.7 meters, and we know you gave me the mass of 396. I'm going to pick that, and I converted that to kilograms. So now I can calculate the density of this box. The density is going to be the mass divided by the volume. The volume is length times width times height, or L cubed. So I get 524 kilograms per cubic meter. The depth that it floats at is the ratio of the density of water, 1,000 kilograms per cubic meter, and the density of this. So that's my wood depth. The crate depth divided by the depth of the water, which is 0.9 meters. And because the crate's not going to move the whole time, as once the water gets below the amount that the crate's floating, then the crate's going to stop. So we're not going to use that 18 hours. We're going to use the 18 hours times the ratio of the densities of the crate and the water. And then I multiply that by the velocity of the water, which I calculate over there, times this time, and I get the distance it traveled downstream. And when I put that in my calculation, I get S equals 3494 meters, or 3494. Or 3.49 kilometers, and we can convert that to miles if that makes you happy, because I know everyone likes miles. I hate miles. Okay, so that's the basic calculation. I'm going to take a picture of this. You tell me what numbers you want to have the answer, and I'll give you different numbers to start with.